kick in here. All right, so we're going to go on to our next section. We're looking at triangle inequalities. So what we're going to look for today is if three sides can make a triangle. Okay, are they long enough to make a triangle when you put them all together, or do they make an open end? Okay, so triangle inequality, if you take 3 straws, be quiet now. If you take 3 straws of lengths 8, 5, and 1 inch and try to make a triangle with them, you will find that it is not possible. This illustrates the triangle inequality theorem. Okay, if you took each of those lengths and I had you try and make a triangle out of them, 2 of those sides wouldn't connect and there'd be a space between them. Okay, you wouldn't be able to have them touch each other. Okay, so the sum of the lengths of any 2 sides of a triangle must be greater than the length of the third side. Okay, so I can take side A and B, so these 2 sides, add those together. When I add those together, they have to be greater than that third side, C. Same thing with the next 2 sides here. If I take side B and C, add those together, that has to be greater than side A. And then A and C, add those, have to be greater than side B. Okay, so adding those sides together has to be greater than the third. So our first example, the measures of 2 sides of a triangle are 5 and 8. We want to find a range for the length of that third side. So it could be any numbers between 2 different numbers. Okay, so by the triangle inequality theorem, all 3 of the following inequalities must be true. So I'm taking those from this right here. Okay, so I'm taking a side, adding on that second side, and it has to be greater than the third side. Adding on a side, okay, side A plus another side has to be greater than the third. And then those 2 added together must be greater than that third side as well. Okay, so you have these 3 different inequalities here. It gets easier. So for each of these, I'm going to solve for x. Okay, so I'm going to subtract 5. So x will have to be greater than 3. For this one, I'm going to subtract 8. So x has to be greater than negative 3. Then I have 5 and 8 makes 13. Has to be greater than x. I'm going to rewrite that so it says x is less than 13. Okay, so if I were to read that backwards, it'd say x less than 13, just so it's a little easier to look at. Now with my number lines below, I want to see where all 3 of these lay in the same path. Okay, so I'm going to plot 0 here, meaning 3 would be somewhere over here, right? And I want to graph this on my number line. Okay, so I want all my x values that are greater than 3. So from 3, we have an open circle since it doesn't say equal to, and all the values greater than it, so to the right. Okay? For the next one, we're going to use our second number line. Okay, so 0 is still right here, meaning negative 3 will be over here. And again, I want all the x values that are greater than negative 3. Okay, so we have an open circle on negative 3. And I want all the values greater than that, so we're going to go to the right. Okay, then the last one. Again, we have 0. I need to plot 13. So 13 is greater than 3, so it's going to go over here. Now for this one, I want the values less than 13. So that means we're going to the left. All right, so with this, I need to find the range where all of these overlap. So where we have a shaded line for all three. Okay, that cuts off right here and over here, right? So my range for that side is going to have to be between 3 and 13. Okay, so what I did to find 3 and 13, okay, I subtracted my two sides that I knew to get 3, and I added my two sides that I knew to get 13. That's how you're going to find the range between those two sides to figure out what your third side could be. So you're going to subtract the two sides that you know to find the lower end, and you're going to add the two sides that you know to find that higher end there. Does that make sense? Kind of, we'll do some more on the back with that. Okay, so I'm going to move on to our next part here. So we want to see if these three sides are able to make a triangle. Okay, so we're going to use this part up here. So we're going to take two sides, add them, and make sure they're greater than the third. Take another two sides, add them, make sure they're greater than that third side. Okay, so each time. So that's what we're going to do for this first one here. Okay, so we're going to add together two sides. So I'll choose 3 and 4. Shh. Pay attention, please. That has to be greater than 6. Okay, so adding two sides together has to be greater than that third side. Two sides greater than third. So this will end up as 7 is greater than 6. I want to make sure that statement is true. Okay, so 7 is greater than 6. That is true. Now I'm going to take another two sides. Okay, so I have 4 plus 6. My last side then, those have to be greater than 3. Okay, so we have 10 greater than 3. That statement is also true. The last two sides I have to add together would be 3 and 6. And that has to be greater than your third side of 4. Okay, that would be 9 greater than 4, which is also true. Okay, so all three of these statements are true, meaning this would make a triangle, so your answer would be yes. Okay, so those 3 side lengths do make a triangle. Now you don't always have to do this much work. Okay, this isn't a lot of work to begin with, but you don't have to do that much work for it. What you have to do is take your two smallest sides. Okay, you want to take your two smallest sides, add those together, and make sure they're greater than the largest. And from that, you can tell if it makes a triangle or not. So you honestly just have to do one of these. So again, you're going to take your two smallest sides. Shh, pay attention. Two smallest sides, add them together. They have to be greater than the third side. You don't have to do all 3 of these, just this one. Okay? Yeah.
What if they equal each other? Like,
we're going to do that one. So in number 2, our two smallest sides are 6 and 9. Okay, so I'm going to add together 6 and 9. That has to be greater than the largest side of 15. Okay, so I get 15 is greater than 15. Is 15 greater than itself? No. Okay, so this would not make a triangle. Okay, so no, since 15 is not greater than itself. Questions on number 2 or number 1? Okay, then we're going to look at number 3. Since all 3 sides are the same, your 2 small sides could just be 8 and 8. Okay? We'll take 8 plus 8, and that has to be greater than the third side of 8. Okay, so if I add 8 and 8 together, I do get 16 greater than 8. That statement is true. So if that statement is true, then yes, these do make a triangle. Okay, with these problems though, you need to show your work. You cannot just write yes or no. Okay, I'm going to make you show your work so that I can see that you actually understand what's happening. Okay? You can put all 3, that's fine. Okay, looking at number 4. Which 2 sides should I add together? 2 and 4. Okay, those are your smallest sides. So we're going to add those 2 together. And they have to be greater than that third side of 5. Okay, so when I add, I get 6. It's greater than 5. Again, that's a true statement, meaning these 3 sides would make a triangle, so your answer is yes. All right, I want you guys to do 5 and 6 if you haven't started those. Good job. It is not Wednesday.
I wish it was Wednesday. No, you know what? The weekend,
All right, I'm gonna look at number 5 and number 6. Okay, number 5, my 2 smallest sides. My 2 smallest sides are 4 and 8. So I'm going to add those 2 together, and they have to be greater than 16. Well, 4 and 8 make 12. Oops. And 12 is not greater than 16. Okay, so this would be no. Since 12 is not greater than 16. Yep. Since 12 is not greater than 16. Okay, then number 6, my 2 small sides are 1.5 and 2.5. So I'm going to add those. And they have to be greater than 3. And I do get 4 greater than 3. That is true. So yes, these do make a triangle.
why do we always have more?
Oh, this part's easy too. It is.
No.
Any questions on those bottom 6 problems? I think you guys are doing pretty decently on those. All right. So we look on the back. Okay, we now want to find the range for the measure of the third side of a triangle if you're given two sides. So now you're only given two sides, and we want to find the range that the third side could be. Well, that's what we did on the front with those number lines, except I'm not going to make you do the number lines. Okay, so if you look back at the front, okay, how did I find this lower bound value? Right here, this 3. I subtracted my two sides I knew. How did I find my upper bound? I added the two sides that I knew. Okay, so if I look at number 7, I have my two sides here. Well, to get that lower bound value, I'm going to subtract my two sides that I already know. So I'm going to take 6 minus 1. So my lower bound would be 5 centimeters. To get that upper bound value, I added. So I'm going to take 6 plus 1. So I have 7 centimeters. So my side can range from 5 to 7. However, it cannot be 5 and it cannot be 7. Notice how this doesn't have an equal. Okay, so this could be 5.1. Okay, that would work. This could be 6.9. That would work. Okay, but it can't be 5 because then it would equal each other. And they can't equal each other. It has to be greater than. Okay, so same thing. Same thing for number 8. I'm going to take the two sides I know. To get my lower bound, I'm going to subtract. So 18 minus 12. Don't write negative. Should be 6. They shouldn't be negative. Okay, then I'm going to add to get my upper bound.
Wait, you read from left to right, so when you put 12 minus 18, you get negative?
Yes, but your side length can't be negative. So it's the absolute value when you subtract. And my upper bound will be 30 yards.
No, Alyssa, I don't want your answers.
Okay? Any questions on 7 or 8? Okay, then do 9 and 10 for me, please. Do 9 and 10. I didn't hear your question.
I asked you what my was for.
Yep.
You really talk with sassy parents.
I'm done. Oh. Happy mushroom. I did that one year too when I was teaching it. I wrote that and I was like,
Well, I'm sorry, but we could have bolded the numbers too, folks. We have to write.
I always did a bigger number. I was trying to small figures. Right. Yeah. I'm sorry.
Say I'm sorry.
I said yes.
Say I'm sorry.
I'm sorry.
Thank you.
All right. So these are the answers that you should have gotten for 9 and 10. So number 9, your third side. We're quiet, please. Your third side should be between 4 and 7 feet. For number 10, your third side should be between 74 meters and 90 meters. All right. Okay, next question. Suppose you have 3 different positive numbers arranged in order from least to greatest. What single comparison will let you see if the numbers can be the length of the sides of a triangle? Okay, this is what we did on the front, on the bottom. So I want you to write out a sentence of their comparison. What did we do on the front, bottom in those examples to see if they made a triangle?
That's all we do.
Write out how you do that.
Yes, I have. When I was 6, we took my bicycle because it was home and we were like, he took my bicycle tire and he took it off and hit it. I don't know. Who takes their kid's bicycle tire off? You guys remember the first time I got grabbed? I don't know. Last time I fought with my father, my dad saw my driving What did you say? Okay, let's see the last time I fought with my father. Last week, November
All right, so we're going to look at number 11. Shh. Quiet. Okay, so if I have these numbers arranged in order from least to greatest, what can I do to see if they make a triangle? Add the 2 smallest sides and see if they're greater than the third. Okay, so I can add the 2 smallest values, and if the sum is larger than the longest side, then a triangle can be formed.
Can you guys shut off, please?
Okay, so this is how I would write this problem out. Okay, so you're adding, shh, you need to pay attention. You're adding the 2 smallest sides or values together. If that sum is larger than the longest side, then you can form that triangle. Okay? So again, that's what we were doing in problems 1 through 6 on the front. Adding the 2 smaller, seeing if it's greater than that largest side. Okay, one more problem. So the distance, you guys need to pay attention so you know what you're doing. The distance between New York City and Boston is 187 miles, and the distance between New York City and Hartford is 97 miles. Hartford, Boston, and New York City form a triangle on a map. What must the distance between Boston and Hartford be greater than? Okay, so if I plot these points, okay, this is New York. Okay, New York to Boston is 187 miles. New York City to Hartford is 97 miles. Okay, we need to find what the distance between Boston and Hartford has to be greater than. Okay, so that's what we were doing in 7 to 10. Okay, but we don't need to see what it has to be less than. We just need to find what it has to be greater than. So to do that, I'm going to take my longest side, subtract my other side. So that distance has to be greater than 90 miles. Okay, so that distance must be greater than 90 miles. What does it have to be less than? How do I find what it has to be less than? You add it. What do I get when I add it?
Oh, I got this. I have this. 284. Okay, so that distance would have to be less than 284 miles, but it only asked for when it would have to be greater than, what it would have to be greater than, and that would be 90. Okay, does that make sense? It does help to draw out that picture of what's going on just to kind of help you along there. Any questions on anything that we did today? You're not going to get it done.